Great. Hello, everyone. So I was telling others last session before you all go back home or go back for a Friday evening. So it's quite difficult. So I try and keep it as engaging as possible. Okay. So first of all, just about an introduction about me and what I've done so far. So I'm Ram, and I've like all of you, some of you here, not all of you. I was a student at NUS ISS about 6 years ago actually. So I started my career as a developer in investment bank, and then I did my masters in NUS ISS. After that, I moved to HP, where I worked in smart manufacturing, where we were applying all the learnings I've done during my masters in R&D and Singapore operations. So we were trying to build things like deep learning in a camera using Amazon Deep Lens. We were trying to understand computer vision, very early days, not like the ChatGPT days that we have now. So very difficult problems then. And then I moved to Mercedes-Benz. This is my first foray into automotive. So there I was the first data science hire. So we set up the team and grow the team there in the region. So automotive is an interesting space where data has not played a big role, which made me hooked there about automotive. Unlike banking and finance and insurance, where data has played a bigger role, automotive is still at the precipice of what you can do there. And then, now I'm the chief data scientist at Inchcape, and this is not very well known in Singapore. I think Singapore is probably well known as Borneo Motors, but Inchcape is the group company. So I'm based here, but I have a global team based in Manila, Chile, and Colombia. Okay. Good. So let's probably do so today. And I think I'm not going to sell Inchcape to all of you. It's not my goal. My goal is to try and show what approach we have taken over the past 2 years that's made us better, and that's made us a better company to work for from a data science standpoint, and what makes us unique in the market as well. So this is Inchcape at a glance for you. So we are not small. We are about $8 billion company, and we have been working for about 175 years in different parts of the globe. And if you see here, data and digital is at the center of our growth strategy. And what we have been doing in the last couple of years, the strategy is to try and see how we can digitize the different parts of the automotive value chain, how we can gather data from it, and how we can make it better for the industry. So like any other business, our business is also done based on customer need. So if you see in the automotive world, most people spend about 5 to 6 hours before they buy a car, and they do all this research online. And the second thing is whether they come to dealership or not. The question is they make only one visit usually. It was 3 visits or 5 visits about 3-4 years ago, but it's slowly becoming 1, or sometimes they even buy the car online. Okay, and the online part of the entire journey is huge, which makes it important for us to think about omni-channel experience, for us to think about personalized experience, and for us to understand what the customer wants and give it to them. And this is an important part of where data and digital can play a big role. So based on this, we started 2 major platforms about 2 years ago. One was a digital experience platform, which is an omni-channel platform. Omni-channel meaning you can buy car through any part of the value chain. You can buy car online, you can buy car through WhatsApp, you can buy a car on a website, or you can go to a showroom and buy a car. That's the omni-channel part of the ecosystem. The second one, which is my team, is data analytics platform, and here we are building predictive analytics, different things that you saw over the course of last couple of days, and you'll probably see that tomorrow as well. Different algorithms we are building to drive the business, and we are integrating everything in a globally standard architecture. Okay. So one of the reasons why I'm sharing this is I'm sure most of you, some of you are from industry, some of you are students here. So when you talk about data and digital, you rarely talk about strategy, and that is one of the reasons. If you go and ask any data scientist who has failed, meaning failed in the sense they have not been successful in their journey, the main reason is because strategy is not in line with the data team. And what's important is you have to have a scenario where your strategy plays hand in hand with your data, so you are able to get the data that you need, and you can grow the business. At the end of the day, every P&L is important, so everyone talks about it. So try and see how you bring both together. So that's why I'm sort of bringing these 2 things. Okay. So if you think about the experience part of it, right? So this is where data science also gets very interesting. So most of us, when you think about how you do data science, you get a data set and you do analysis on it. That's the usual method that you do. But there is also the empirical part of data science where you have to collect data, which not a lot of courses teach you. Okay. So what's important between both these platforms is this platform generates the data and that platform analyzes the data. So both have to talk to each other so that we get the right data and we get the right insight. And the insight is wrong, then you try and improve the data as well here. So both of these parts bring the empirical part of data science as well. Okay. So this is what I call as scaling AI and doing AI, right? So most of you have tried building ChatGPTs, have tried building some analysis, but that's the doing part of AI, right? You can do that, but that's a problem data scientists can solve. But when it comes to scaling, it's a problem that not a data scientist can solve. You need more than that. You have to understand how digital is your business, what are the data points, like I said, different data points that you collect in the ecosystem, how automated is that, and try to involve data scientists from day zero. And this is probably the most important rule, because data scientists know what to collect and also they tell you how to collect, whether you should collect daily or monthly or yearly, what is important, how often you should collect. All of these are important questions. And this comes very early in the design phase. So if you don't do it, if you build, collect everything and then you finally try and go back, you'll miss a lot of things that you're missing in collecting in the ecosystem. The last one is on people, process and purpose, right? So the purpose, the reason I say this is you should also know why you're collecting it. So more often than not, I find databases just there, but nobody knows why anybody is collecting it. So the purpose part is important, and people is also very important. So people is important mainly because they are the ones who are generating data most of the time. So you will rarely find all data automated. So the people who are manually entering data are the ones who are corrupting the data also sometimes. So having these three sorted is important. Okay, and both are not the same problem. So even if you have a very good model on your POC, you will be not be successful when you try to scale it. So when we started building this idea, so this was the framework that we had, and we also wanted to do all of this at low cost and be very fast as well, which is not an easy challenge 2 years ago. The kind of things we did was two things. The first thing we did was taking a venture capital style product selection. So what I mean by that is so I have a team of 50 data scientists internally. Everyone comes up with a different approach and we try and see what approach we want to fund, like a venture capitalist. Okay, so we have a pool of money every year and we have a lot of ideas and we see which idea can really scale and create that value. That is one. And the second one is, don't treat your data and algorithm as a separate mystic kind of entity. Treat them as products. They are not going to be perfect. Okay, there is this big thing that data science can and AI can solve everything for you. It's going to give you absolute magic, and that is completely false. So I'm sure some of you have learned it by now. So it is going to be very difficult, and it involves a lot of change management, people management, and other aspects as well. Just having the algorithm is not enough. So that's why you sort of build a product mindset. So when you think about product, you're not going to be perfect in day one, but it's a work in progress. So you can try and understand the roadmap of the product, how can you improve it over time. And the reason why this is important is I'll cover that later. So you may have a good algorithm, but it may not be embedded in your business. So what's important is how you embed this as part of the business decision making, and that again the product mindset would help you. So these two are two decisions that we made, which has really helped us. So now from having 0 algorithms in production, we have over 200 algorithms in production now within just 2 years time, and all of this is creating value to the business. So it's not just someone running a notebook at one cluster. All these products are creating value to the business. And you can also go to one step further, because you have the VC style here. You can know what's the value it's creating financially as well. Okay. At the end of the day, data scientists, though it's a R&D kind of an area, it does have some P&L impact, and it's important that you understand and you amplify that impact clearly in your organization so that you can create that scale effect. That's also something we did differently. So like I said, many proofs of concept, small different ideas, and we scale what works. Okay, and the scale what works is also something that we follow blindly, because in 2021 we had about 25 different algorithms internally, and in 2022 we only scaled 4. So it's not about scaling everything, but we scaled 4 to almost 80% of our business, which is like 40 different countries. Okay, so instead of scaling everything, try and understand what you can scale, what can create that immense value, and try to make better money through that. And that's a smarter strategy than trying to build everything that possible. Okay. Another important thing we did was, like I said, be obsessive about activation and business value. So more often than not, data scientists are taught as technical people not knowing business, right? I know some of you have heard it before. So at the end of the day, you are impacting the business in some shape or form. So how do you obsess about what value you're creating is important. And this is where Amazon, Google, they're different from other people, because they obsess about value from day zero, right? They understand what value you're creating. So you should be able to articulate what's the financial impact of your algorithm and how can business benefit from it. So that's an important thing to do from day one, so that you can really make it better over time. Otherwise, it's just a fancy algorithm and it's going to be lost in 3 months after the next project comes up, right? So also something we did differently. Okay. Another one is a set menu of global products. So this is more an Inchcape context, but this can apply to companies where you have like a lot of different things happening. So more often than not, data scientists, because they are very research focused, they end up getting too personal in terms of their product, right? So they try different things. I've seen one data scientist building 12 different algorithms in 1 year. Then what happens is when you have a team of 50, you have a lot of products, and these products, everything is good, right? And POC stage, everything is good. But what's important is what can really scale, and that can happen only when you have a standardized approach. Very similar to an assembly line in a factory, right? Like what Ford started. It was standardized, it was clear, and that helped them to scale. And likewise, you should have a set menu of products that you can scale. And this is very important, especially in huge organizations where you have a lot of unnecessary projects happening with no business value. Rather, you can try and focus on 4 or 5. So for example, if you take Apple, right? How many products do they make? They make iPhone, they make iPad, they make Mac, and they are making so much money from it. But if you take some other company, they make 20 different products, but they don't make enough money. So you put all your focus on 4 or 5 and create an incremental value, and that is a good strategy to have. Another one, again, a technology problem. So I'm sure some of you are working in enterprises where you have everyone working in different stack, right? You have Singapore working in one stack versus Malaysia working in another stack versus India working in another stack. So when you try and have everything in different stack, everything then generates data, but you have to spend a lot in harmonizing this data. That becomes a huge problem as well. So automation is not something that is by default. As a data scientist, you should also think about scale and standardization, and building it on a common technology stack helps you achieve that standardization, which means that I can build one algorithm once for a market, and I can just copy paste that across 40 markets, 50 markets, because it's the same stack. The data structure is the same. And finally, it's housed on one global data lake as well. So again, an important one. So if you have segregation here, again, going to make it complex. So it's actually a very simple strategy. So if you think about it, many proofs of concepts, scale what works, be obsessed about business value and activating it. Activation is ensuring they're using the model, set menu of products, and on a common technology stack, finally in a single data lake. You put all of this together, essentially becomes our strategy. Okay. And this was something that we did very early in the pipeline, because we never looked at data science as a cost center. Data science is a profit generator. So how can you generate profits from data is super important, and this approach helped us. So your recipe can be different, but as long as you follow this structure, I'm sure you will not fail in your data science project. Okay. So I think I've spoken a lot about strategy. Let's go for some execution. Okay. So here again, how aligned you are to business is super important. So this is Inchcape's end-to-end value chain. Okay. So we start in product planning, we do some brand positioning, and then we buy the cars, then we nationalize the cars, what something called as homologation, and finally we sell the car. Okay. So end to end, there are different parts of the value chain where data science can help. So identify what algorithms can help you in the end to end value chain. And again, try to bet on the big ones. So here if you see, we spend a decent amount of money for every year. So how can you understand where you spend money in marketing, which digital spend attribution will solve. Okay. And a lot of leads come to our websites every day. So I in fact have an algorithm that tells you within every 5 minutes what lead is there in your platform. That's real time lead scoring. Okay. Then once you sell the car, the customer is going to come back in after sales. So how do you predict who's not going to come back? That's after sales churn. So if you see the entire ecosystem, it's sort of in line with the value chain. And this makes it simple and easy for anyone in your business to understand what you're doing, right? You're not solving some elusive data science R&D problem. You are helping the business move the needle. You're helping them to do their operations better. You're helping them improve their efficiency and their effectiveness. So that's what is clearly visible here. Okay. We also do a lot of pricing problems, which is quite interesting as well. So this parts pricing optimization is one of my favorite use cases, where we have 10,000 over parts, and we want to understand how to price these parts. And here we use a lot of econometrics data as well. So we understand different parts in time, what's the quantity, what's the price, and finally we get the optimal price. Okay. Any questions on this slide? Just wanted to spend some time. It's quite a busy slide, but it has all the elements that I'm going to cover later.
So you predicted demand and price forecasting this.
Mm-hmm.
Like, how do you get that data actually? It's like the demand data.
So demand data is something, so most of the data for this comes from internal sources. So we have the car sales data for the last 20 years. So based on that, we can build a demand curve, understand what demand is going to happen. Plus we also have external data points, things like Google Trends, for example. We use Google Ads, all of that, we get data from that, and combination of all of this helps us predict what's the demand going to be in the future. On the pricing side, again, it's a Bayesian problem. So you try and understand what kind of quantity you have, what kind of price you have, and you can do different pricing curves there and see what works from that.
Does the currency conversion plays a role?
It does play a role. Exchange factor does play a role. So you'll have to accommodate the spot rate in the market. What time did you buy? When you're going to sell? What's the difference? So we accommodate for all of that as well. Okay. Yeah.
I want to focus on the after-sales market. I want to know how you use the data to help you identify whether the customer will go to the install maintenance or not.
Yeah, very good question. So after-sales churn prediction is also one of our major use cases. So the way we do that is a combination of customer behavior and also based on, we don't have that now, but I wish we have, like telematics data, right? So in certain cars, we get data about how the car is functioning, and we know like fuel is low or the brake pad is loose, and we use that information to understand that this car needs service, and then we try and call that customer, target that customer. So where churn prediction plays a role is behavior, right? So obviously, I'm not sure, I think in Singapore, the car lifetime is only 10 years. So you typically see customers who are in the 5th to 7th year not coming back to service because they're not willing to maintain their car, they're going to sell their car. So how do you capture that impact and how do you entice them to come back? Okay. So this is again like the algorithm will only give you a prediction, right? It'll tell you who's not going to come, but it's not going to stop that person from not coming, right? So that's where your marketing and other materials, also ecosystem plays a role. How do you communicate this insight to marketing, and what can marketing do on their side? Can they call the customer? Can they do an email ad? Can they do some advertisement to retain them? So that's the whole ecosystem play.
Okay. How did you identify the key factor to?
Yeah, it's from a technical standpoint, it's a classification problem. So we have like an algorithm that tells you what's the propensity for them to leave, and based on that we target. Good. So let me move. So I have two things I want to share in terms of in-depth view. So first thing is on real-time lead scoring. This is also one of our important problems for automotive. So if you see, more often than not, we have a lot of leads coming in into our ecosystem, and most leads engage with the website form. And once they engage the website form, they show some activity. They can join a mailing list, they can download a brochure, they can probably book a test drive, right? So all these are different actions the customer would do, but all these actions are not equal actions. So booking a test drive is a high propensity action. It tells me that this customer is more keen to buy the car, so I should treat this customer as hot, right? Whereas downloading a brochure is probably a warm lead, so he is not a hot lead. So this is the rule-based approach. Okay, so this is pretty good. It's smart, but it's not intelligent enough. Where the problem is because I see a lot of customers booking test drive, so I will have a lot of hot leads. Just having singular features is not enough. So you should have more than singular features, and that's where we use an algorithm there on the right. So which is also propensity based algorithm. So we use marketing actions, we use things like online behavior, what's the ownership status, what's the walk-in activity, what are they doing on the showrooms. We use all of that, bundle that into our real-time lead scoring model, and finally use a probability propensity based algorithm to say who is hot, who is cold, who is warm. Okay, and then we can also strategize in the end, like I said, focusing on sales teams, contact centers, and marketing team. Okay, so if you see this entire end to end, right, this is not just an algorithm. If you think about it, this is the product. Okay, because you have marketing, you have sales, you have website, you have the data science team which builds the algorithm, the small part there, but you need all these enablers as well to create value. And when you think about setting up data science teams, people just think about hiring that best talent, but it's not just about hiring the best talent, but hiring the best ecosystem of talent. So you need the right marketing team, you need the right sales team, you need the right Salesforce architecture as well in this case. So all of that is also important for you to create that incremental value. Okay, so this algorithm is live in over 30 markets globally, and we've been able to improve our business significantly with this. And overall, the major benefit is because we are using a smarter approach here, we have lesser number of hot leads going to our frontline teams. So when I say hot lead by the algorithm, I'm very certain I'm going to sell to them. So I can efficiently target my marketing accordingly and make more money in the end of the day. Okay. The second one is on churn, which is like the question that gentleman had asked before. So here we use different features which forms the basis of our intelligence. So we use things like distance from the service center, right? So where are you located, where is your home, and where is the service center, how far both are, and what's the days left in your warranty. Typically people who don't have warranty typically churn, and number of parts you replaced in the car to understand how good is your car, and service history, what's the cost, what's the frequency, how often you come, all of that. Put that together again into an algorithm. You can understand who is going to leave you. Okay, so this algorithm is like I said, is a work in progress. So as and when I get more data, it will change. So during COVID, we had to revise our algorithm. It's not, this is again on there's something called machine learning operations. Just building the model is not enough. It's not universal. You should also maintain your model as and when you get new information. Okay, so during COVID, we used a lot of external data to understand the market better, and how can we improve our sales, because you can't have customers come back to service center because of COVID. So we ended up doing something like a customized pickup of a car. So there'll be a person going to the ecosystem, going to their house and picking up the car for service, rather than bringing the customer to the service center. And this insight we got because, again, like this algorithm said, everyone is going to churn, right? And then your marketing and business changed after that. So you should constantly be aware of different trends happening in the market and updating your intelligence within the algorithm so it can be used for a longer period of time. So in this, so like I said, data analytics is not just something that we do within Inchcape as a sideshow. It's sort of helping us build our bottom line and top line as well. So with this, we have able to have more customers, almost 26% in one market, and we improved efficiencies across time spent in hot leads. So our sales agents are spending less time on non-genuine hot leads. That algorithm is helping us, and we improved our revenue by over 10% over time. Okay, so it's helping us bring more customers, improve efficiencies, and bringing more growth. And this you should be able to do. Like I said, you should not about building a fancy algorithm or the technical aspect of it, whether it's a neural network, deep learning, even if it's any other AI transformers. What matters ultimately is, are you creating that value for the business? So you should be able to frame this, and this is actually an important role in the company. So there is something called analytics translator. So how do you bridge technical team and business team, and how do you show value in your products, is something that someone like this would do. Okay. In our case, every data scientist, unless they can't frame this, I don't even approve the project. So it's important that you are able to frame your business value clearly. So now I've sort of combined, like I said, I've shown through most of our data analytics platform, and now you sort of see over time why Inchcape is doing this, right? So if you see a vehicle, you can think about a vehicle as just one vehicle, but a vehicle can be has a lifetime as well, like humans, right? A vehicle probably has a lifetime of 20-25 years if you think about it. So we do the first sale, which is the first 4 years of the car. Then you can think about second sale, third sale, fourth sale. And every sale you're generating data about the car and about the customer as well. So both these have to go hand in hand, and it's important for us. So the way we see it is, as the automotive value chain slowly increases, so we can sell the first car in Singapore, and we can take the resale of the car probably in some other country, and then third sale in another country. So it allows us to use the data of the car across different sales, and that helps us to amplify the value as well. This is what we call as vehicle lifetime value. So you can also predict the value of this as well, depending on number of accidents in the vehicle, number of repairs in the vehicle, what kind of driving behavior was had in the vehicle. Based on this, you can predict the lifetime value of the vehicle as well. Okay. And the DXP team, the experience platform and the analytics platform, the products that we are developing in both these places is helping us to create this amplified value. Okay. Great. So I know it's the last session, so I don't want to keep the full hour, but just to sort of close, right? So how data has helped Inchcape is like a big story, and it's important that you think about not just your past and like a company that is like 175 years old, not worrying about the future. They have invested in the strategy and they have been helping to improve in the strategy. So this is done by an independent authority. We have been able to move from like a challenger to a leader within a span of 2 years, and this has also helped us to acquire more companies. So the way we are progressing now is we are acquiring more companies, we are having bigger market share, and with that we are also using our digital tools. So because we are sort of having platform at everything as a platform, you can buy a new company and use your platform there, and you're sure you're going to make more money than somebody who's not using AI. Okay, so that's the difference we are playing in the region. Okay. So in terms of our team structure, just a glimpse of that. So one thing that we do is we don't just hire data scientists. We have different pillars within the team, and one important pillar is the data science and AI pillar, which you see on the left. But it's also important for you to have a BI pillar, which is a business intelligence pillar, that's going to make data accessible, reliable, and structured in good quality. And then you have the analytics or consulting pillar, and this is the analytics translation I was talking about, right? It's more consulting, product management, but that is super important for you to get your product used by the business and to make it create that scale impact. And finally, you have the full stack pillar who can do end to end. Okay. Between all these pillars, there are two levels as well. One is on data quality and governance, which is also very important for you to have, and the second one is ML ops, which is machine learning operations. So once you build something, you can't forget about it. You should ensure that you maintain it like a product, which means you're going to operate it regularly. It needs its own oiling, it needs its own maintenance. And that's what ML ops do. So they check the model validity, they check if the model is stale, they check if the model needs more features, they check if certain features are drifting. You might assume something, and can change in the future. So there's always a drift component as well. These are like things MLOps do, and they communicate this to data science as well, so that you can improve the model, a second version, third version, things like that. This is how we have structured the team so far. Okay. So I want to end on a bit of a philosophical note. So there have been different schools of thought in terms of how you run your data science teams, right? So typically you think about a conductor like one lead. If you think about it, he sort of tells you what to do, how to do it. That is probably good, but not good enough. What you really need is more like a jazz band, where everybody knows what's their goal, what's their vision. If you think about how a jazz would play, someone will start something, then you will add on it, you will build on it, and then you will finally get that symphony, right? It's not some one person controlling. And this is very important for data science teams to do, because at the end of the day, everyone is super capable within the team, and it's not about one idea, it's about the team's idea at the end of the day. So how do you work like a jazz band is important. When you structure teams in the future, if you already have teams, that's great. Try and think about designology all the time. And that's really helped at least me to ensure that the team is cohesive and together and building the right products. Okay, good. That's me. Thank you. So if you want to connect with me, you can use this code, and I think there'll be the feedback form after as well. Okay. Any questions? Yeah. Where based? So the directors are based in Singapore, but most of the team is based in Manila, Philippines, Colombia, and Chile. So overall, we are about 200 globally. Any other questions? Yeah, sure. Yeah. Yeah.
So do you have IT staff who help you, or the data scientists?
So data scientists build the algorithm, the brain behind it, but just the brain is not enough. You need the body, you need the form. The other things is done by IT, is done by BI, sometimes done by some other shadow IT teams. So it's a combination there. So the brain is built by data scientists, that's right, and that is the team that I lead. Yeah. Yeah.
Is there someone who is actually overlooking the interpretability or the explainability of the model that is built?
Yes, we do. A good question. That's actually a big problem as well, because more often than not, you're building models, but nobody knows how to interpret it, how to explain it. So we use LLMs for that. So we have a large language model that actually reads through all this data and explains, for example, if I say churn prediction for this customer is going to be 70%, why is that 70%? So it explains the reasoning behind it as well. So this is something we are building within the team, like an LLM that can answer this question.
And you use Salesforce as your CRM or?
CRM, Salesforce is a CRM, yeah. Yeah.
So my question is, do you prefer the white box model or the black box method?
I think it's very tough to answer that question. So again, it depends on the stakeholder, if you ask me. So if you see 5 years ago, everyone wanted white box models, right? People wanted to know what's happening in the data. But now you have in the world of LLMs, you don't really question the ChatGPT why it's giving this prediction, or you don't ask that question. It's a black box, right? You trust it. So trust of AI is getting higher and higher. So if trust gets higher, then the whole explainability concept becomes obsolete because you trust someone, right? So I think personally I prefer black box models, mainly because it's easier sometimes to not. So when you open up your insights and features, there are chances where somebody can cheat the model with a certain set of features that they want to add. But when data scientist holds that into his knowledge base and not biases that decision making, then it's better. So that's why black box, at least from a usage and data scientist standpoint, it's better. And I think over time, that's how the future is going to be, more black box. Yeah.
Okay, thank you. So do you usually use black box model in the procedure
Yes,
for
yes.
like
So
price prediction?
yes,
So,
price prediction we use black box, but we use Shapley internally. Data scientists would use Shapley to understand why we are predicting, but I will not open that up to everyone. So that's only data scientists can see basically. So when you do white box, you have to explain it to everyone, like a more regression based model, for example. Yeah.
okay, thank you.
Yeah.
So for the after sales churn prediction, um, different you had one of the features where service history, right?
Mm-hmm.
So for different cars, they have different service history.
Mhm.
So how do you normalize all the cars as once, or do you?
So every car is unique. So the prediction is for every car, right? So every car will have its own churn prediction and own churn score.
I mean, every car for a particular model, like for a
No,
company.
every car customer combination. So every car customer is one car in my. It's like the most atomic part of my data set. So for that, I will have its own service history, its own vehicle features, its own distance, all of that, and that
That's
is.
like your current web data. So
Mhm.
when you're training the model, it used to be the previous customers. Do you match like that?
Yeah, we do all this matching, and we ensure that it's all
It's
linked
like
and
each model is for each company car, or is it like all?
not at the model level. It's at a, like I said, car level. So it's like a license plate level, for example. So every license plate is one car, right?
Yeah.
One car will have its own model. One car will have its own. So that's the granularity we go to. It's not aggregated, per se. Yeah.
I want to also focus about the after sales market.
Mm-hmm.
And when I also have some experience in the vehicle data, and
Mhm.
when I processing this data, I will face the problem. There have lots of missing value, and if we want to predict do some prediction by this value, the result might be wrong. How can we deal with this?
Yeah, this is the 101 of data science, right? So you have missing data, you have corrupted data, you have data that is wrong, misrepresented. So we do a lot of cleansing on our side. So we use some statistical techniques to fill the missing data. And if you're not able to logically fill that, we remove that record. So because we have a lot of data, ultimately it's about like what you feed into the model. So garbage in, garbage out, right? So if you're feeding in not the right information, it's going to throw garbages out in the prediction as well. So it's important that you cleanse the data, make it sanitized and certified, and then you build the model after. That's the data governance part here. So you see this quality and governance there. So that team ensures the data that the team is using is of good quality.
And from my previous experience, we only processing the vehicle information data,
Mhm.
and seldom face
Customer data.
Customer data. How do you identify the specific customer behavior?
Yeah, it is a tough to link. I think it's very similar to the question he asked as well. So it is quite difficult to link both. But ultimately, if you think about it, at the end of the day, when somebody comes to a service center, the car is not coming there. The customer is driving the car there. So the customer also has a feature and basis as well. So we've done some interesting study in some markets where when a chauffeur comes, chauffeur is somebody who like drives the car for someone else. When chauffeur comes and drops the car versus a owner coming and dropping the car, right? And we compared both behaviors. And we were able to see that when an owner drops the car, he generally wants to do more on the car. He wants to ensure the car is really taken care properly, right? Whereas when it's chauffeur driven and chauffeur is just doing the routine service, he just wants to get down with the service and go back, right? So that's why the customer, who the customer is, what his role is also important, and that linkage can help you get better insights.
Thank you.
So that means the same car will be different in different markets.
Yeah,
Like
different markets, different sometimes.
car model in a different.
Yeah,
market.
don't look at it at the model level. So just look at it at a just as a car level, right? So there you will find different insights.
As for the past 3 years, I guess see more of Industry 4.0. So has it accelerated your data collection through IoT sensors in the service space? Like You have mentioned predictive
Yeah.
maintenance. Right?
Yeah, yeah.
That's one of the
So
upcoming new.
correct. It's a good question. So the difference is the fact that we are more of a sales and marketing focused company. So we don't build cars. Okay. So the challenge mostly is on sales and marketing side, not in developing cars. So if I was in Mercedes-Benz, yes, what we do is we get data from every car. We try and see what can we improve on our factory as well. So one project I did during my HP time was to link factory and field, right? So you have HP printers here. So I can tell you for this printer which factory it was manufactured. You can link that end to end. Okay. So it was not blockchain days. It was the old days. You have to really understand data at every level and link it. Once you link it, you can know this printer is failing now because it came from this batch in factory, and this batch in factory had so many number of defect records, defective printers. So that linkage is again important, which is not a data science problem, which is again an engineering or a data collection problem. And that's where you need help from other teams. You will not get Kaggle data sets in industry, so please, if you are doing that, just get that reality check. So you will spend a lot of time in fixing data more than building models. Yeah.
So how often do you update your model?
Yeah, it's also a very good question. So again, depends on business cycle. So for example, if it's going to be my pricing algorithms where I use exchange rate factors, I refresh my model every week, sometimes even every day, right? Because my prices would be different. But if it's something like churn, I probably don't do once a year, right? Because the behavior of customers will not change that often. But if you have some extraordinary event like COVID, then you have to update the model again. So again, like I said, it's about being aware of your surroundings, understanding what's happening in the market, and accordingly applying that in your model. So it's like a living and growing organism, right? So you have to give it what it needs at different points in time.
So how do you put the accident into your model? I mean, the things that suddenly happen.
Yeah, these are called black swan events. So it is very difficult to predict that.
Yeah.
Okay. So the way we do it now is more reactive. We are not proactive with it, but we do have some historical data, right? For example, right, you had 2008 crisis in global financial crisis, right? So I use that data for churn for COVID to understand what is the similarity between these two events. These both are black swan events, and both led to different things in the industry. And interestingly, there was a correlation between these two. Okay, so you can go back in time, history, and see what can help you,
So
right?
you actually build a new model based on the crisis. Right?
Correct. So for crisis, usually you go for a specific model, not for the usual scenario, right? So it is not always like a data science algorithm. It can also be rule based. So we also switch back to rule based. So you should not say I want neural network to work. It will not work even if you have it can be a complex deep learning model, but it will not handle crisis. That's where you have to go back to critical thinking and try and see how to apply basic common sense and apply some rules and to handle that crisis. Good. I think I have 5 more minutes. Any other questions before we close? I hope it was useful, and do connect with me if you have any other questions. Happy to answer that as well. Otherwise, I'm good. Thanks for spending the time on a Friday evening. Thank you.